polar and the exponential form of the complex number. And so we'll primarily be concerned with the polar form. The exponential form is self-explanatory, which would be there. We can, represent the complex number. Uh, it's very similar to what you do in the Cartesian plane. It is called Argand plane. There's not much of a difference. I don't see any difference in any way. Suppose there's a complex number which is x plus y times I. This is real, and this is the imaginary part. All right. I can think of it as that, look, I have a real line, and then this is imaginary line. So any number will be I go some distance x and I go some distance then y, and then I reach here. So I call it x, I call it y, and this point P, I call it x plus yi. Correct? Now this is angle that is made with the positive direction of x-axis. Remember, as a convention, I mean, just as a convention, this angle has to be written in such a manner that it lies between minus 180 and 180. So from here to here, right, we will, remember this always. The other thing you have to remember, this theta angle is the angle between positive direction of x-axis and the complex number. So if the complex number is here, then I am not looking at this theta. No, I am looking at this theta. I'll write it in some other way, that it lies between here and here. There are ways and means of doing it. Or if the complex number is here, the angle is not this that I'm looking at. The angle is this that I'm looking at. So 2-3 things we have to remember, that the angle theta, which we call the argument, right? This thing, which is the hypotenuse of the triangle that is formed, it is called the magnitude of the complex number. And how do we arrive at the polar form is like this only. So for example, this is x, this one, this is y, and this is r. So by simple, trigonometry, which you learned in class 10, if this is r, this is x, this is y, cos theta can be written as x by r. This gives me x is equal to r cos theta. And similarly, sine theta can be written as y by r. So I get y is equal to r sine theta. The theta that I was talking about, I could either write x by y or y by x. Cot is difficult to evaluate. So I would write y by x is equal to tan theta. And then I calculate theta is equal to tan inverse y by x. So how do I write this number in polar representation? In place of x, I will write, so x plus yi will be written as r times cos theta plus I times sine theta. You take, this is the correct version, right? You can write r times cos tan inverse y by x plus I sine tan inverse y by x. This is, this is as simple as it gets. Look at some of the problems, which is find the polar form of -4 plus 4i. I would strongly urge you to plot the complex number before you do anything, right? So if I look at my, Cartesian plane and convert it into Argand plane, -4 will be here and +4 will be here. So complex number will be here. Correct? So this is going to be 4 and this is also going to be 4. Really? It does like this? I didn't know this. This is going to be 4. Automatic shapes are on. Let me just turn these off because they're like crazy. All right. So how do I write it? First of all, I'll calculate this value, which I called R, or the amplitude, or whatever you call it. Now, this is R is equal to x squared plus y squared. So can I write 4 root 2 straightforward? So the value of R is 4 root 2. Correct? How about theta? I have this theta, but I need this theta. This is my requirement. So what is this theta? This is obviously 10 theta is equal to, I'm writing magnitude 4 by 4, which is pi by 4. But again, I don't need pi by 4. I need this. So I can get this by, let's say, from 180. If I substitute, if I decrease this angle, so that means the angle that I require, or the argument, will be pi minus pi by 4. So pi minus pi by 4 will be equal to 3 pi by 4, which is my theta. I can write it as phi if you want, which is my theta. So I will write now complex number as 4 root 2 sine 3 pi by 4 plus I sine 3 pi by 4. This is the correct representation. Exponential will come later. We'll write everything in exponential form once we learn it. Let's look at this. This goes to third quadrant. So it says minus 3 minus 5 times I. Please plot it. It takes 1 minute to plot it. Nothing else. This will be minus 3 here, and let's say minus 5 here. We can that. So the point will be like this. This is minus 5 length, and this is minus 3 length. Sorry, this is minus 3, this is minus 5. All right. Now, how do we do that? This is angle phi. Remember, my argument is this angle, and it should lie between minus pi and plus pi. That means from here to here. So I'll have to convert it. Let's see how do I do that. Let me calculate the modulus, or the amplitude, or the magnitude. You could say 10 things for all I care. So it would be Z modulus, or R, or whatever you say, will be 3 square is 9, 5 square is 25. So 9 plus 25 is 34. How about 10 theta? All right, let's see what is 10 theta. So 10 theta will be equal to modulus 5 by 3. Now, if you remember this was 3, this was 4, this was 5, right? So 5 by 3 will be sec theta. And if I have to get this value of 10 theta, I can't use this. 1, 2. I can use a calculator to get this value. But in any case, if I say the theta is equal to 10 inverse 5 by 3. All right. How do I get this angle? what I have is this angle and minus pi plus pi. Can't I take the negative of this angle? And the point that I'm trying to make is, if I measure this angle, this will be minus pi, right? So I can say that, look, this angle can be calculated as minus pi minus this angle. So this angle would be 10 inverse pi by. So you would see in lot of books, and this in a lot of books, this will be minus, because I'm going, the angle is measured like this. This a rule of clockwise, anti-clockwise. The convention is absolutely up to you, right? So that's why I'm not mentioning. I'm saying if an angle measured like this is positive and this is negative. So all I'm saying is I have to deduce this angle from pi. So I have to deduce this angle, which is negative, from minus pi. This is what I've written. So my argument will turn out to be minus pi plus 10 inverse pi by, right? Okay. And then let's do this problem as well, which is minus root 3 plus I. So let's plot it here. This is a line. Then this is a line. Oh, it didn't do well. Okay, fine. You can accept it. So this is x and this is y. Negative x and positive y, I'll come somewhere here. So I would say that, let's say this is root 3 and let's say this is 1. So the point will be somewhere here and I will plot this. So this is how my number will look like. This is an angle phi. My argument is this. Please remember, this is my argument, correct? And this is 1. So first of all, let's get amplitude, magnitude, whatever you say. So the value of R would be root 3 squared minus, doesn't matter, plus 1 squared under root. Root 3 squared is 3, 4. R is straightforward 2. So this guy is 2. Now I have to get this theta, and this is phi. So I'm sure I know 10 phi. So 10 phi is 1 by root of 3. Now this is 1 by root 3 is 1030 degree. So it is pi by 6. But this is not my argument. My argument is, from pi, I will have to reduce this angle. So pi minus pi by 6, which will be 5 pi by 6. This is my argument. So if I write the complex number now, the complex number will be r cos theta plus I sine theta. So r is 2 cos 5 pi by 6 plus I sine 5 pi by 6. This is the correct notation. All right, let's do this. Now let's go reverse. We've been asked that write this number in the rectangular form or the Cartesian coordinates. So that's okay. That's not that difficult. I need to get the value of cos pi by 3. Everybody knows is half. And sine pi by 3 is root 3 by 2. So my number becomes 5 times 1 by 2 plus I root 3 by 2. This will become 5 by 2 plus 5 root 3 by 2 times I. This is the notation in the in what do we say, the Cartesian form. I'm so sorry. I'll take one more example so that you'll have a clarity as to what we're talking about. So this is 9 and then this is a line. I'll take a complex number in the fourth quadrant so everybody knows what we're talking about. In the fourth quadrant, x is positive and this is negative. So can I take root 3? It is easier to take minus I, correct? So this is root 3 and this is negative I. So let's say this point is root 3 and 1.732 and this point is, let's say, little 1. So the number will lie somewhere here. So I can say that, look, this is my number here, which this is root 3 and this is 1, this is negative 1, please remember. And this is some angle phi. My argument is this angle. That's what I was trying to tell you. Why am I doing it? So let's get the R. R will be root 3 square is 3, 1 root, it is 2. Let's talk about phi. All right. What is phi? Let's say 10 phi. This is, let's say 10 phi. So 10 phi will be equal to 1 by root 3, and which is nothing but pi by 6. But this is not the theta that I was looking at. Either I subtract 360 out of this, but that will exceed my limit. My limit is that argument has to be between minus pi and pi. So instead, what I'll do is I'll take this angle in the negative connotation. So my argument will be minus pi by 6. This will be my theta. So the complex number that I will write now will be 2 times sine minus pi by 6 plus, see what I've done, 2 times cos minus pi by 6 plus I sine pi by 6. Now cos minus theta is cos theta. So the final, we can write cos pi by 6 minus I times sine pi by 6. So the only point you have to remember is how do you calculate the argument of the complex number. Now let's come to the exponential form. Now for the exponential form, Euler, one of the greatest mathematicians of all times, he gave an identity which even I don't have the idea how did he get there. I have no idea. E I phi or I theta or whatever, I don't care, is equal to sine phi plus I, oh God, cos phi, sorry, cos phi plus I sine phi. I don't know what happens sometimes. Now, this is intuitive. Intuitive in the sense that you will study it later. You can, have an infinite series which we call the expansion, right? The expansion of e to the x is 1 plus x squared by 2 factorial plus x cubed by 3 factorial and so on. People write 1 factorial. I am okay with this. Correct? Now, in place of x, if I substitute I phi or I theta or whatever, so I am saying x is now I theta. So what happens? See. So this is e to the x, which is 1 plus I times theta. I was wondering. I times theta by 1 factorial plus I squared theta squared by 2 factorial plus I cubed theta cubed by 3 factorial plus I 4 theta 4 by 4 factorial, so on. So this will turn out to be 1 plus theta. Now this is minus 1. I squared is minus 1. So it will be minus theta squared by 2 factorial. I cubed is minus I. So it will be I times theta third by 3 factorial. I to the 4 is 1 because I square is minus 1, square is 1. So it will come out to be theta 4 by 4 factorial. I'm sure you'll find it boring at this point in time, but once you do Taylor series, Maclaurin series, you will understand. And then you can have the imaginary and real part separated. When you separate the real part, you get here 1 minus theta squared by 2 factorial, 4 by 4 factorial, and then these odd powers. This is expansion of cos theta, and this is expansion of sin theta. So therefore, you can write e to the I theta as cos theta plus I sin theta. This is called Euler's formula. Now we'll go back and write everything in this form, whatever we had written. Let's go back further. Our first answer was 4 root 2. So I can write, simply that this is 4 times. Damn, this is crazy. Why should it even happen? I have no idea. Let me just. Okay. Because the line gets straighter. It makes it hard. That's silly. Okay. Now this is 4 root 2. E to the I 3 pi by 4. Remember e to the I theta? Let's go to some other thing that we did. This was the number, so I can write it will be 2 e to the I 5 pi by 6. Right? This will help when we will, talk about the roots of the complex number or roots of the unity and so on and so forth. So this was about the representation. I will see you next time.